So we will start. So I will quickly recall some concepts which are very important. So in last lecture we were there with the combinational logic design using CMOS. As you know that CMOS stands for complementary MOSFET, which is having PMOS in the pull-up network and NMOS in the pull-down network, and it implements invert logic, that is the complement logic always. So whenever the bar is given over any expression, means you can implement that particular function directly, that I told you, and we have taken some poll questions on that also. So this is basically two rules you need to remember. First is that whenever A plus B comes in picture, for NMOS you need to draw parallel combination of two transistors, and for A into B, for NMOS you need to make a series combination of NMOS. Opposite to that you need to do for the PMOS. So I told you to remember only one to avoid the confusion. Okay, so here how to recognize what diagram you have drawn. Suppose this is given, you have drawn this diagram. How you have drawn that PMOS will be in the pull-up network and NMOS will be in the pull-down network. Okay, so this is the pull-up network having PMOS devices, might be connected in series, parallel, or combination of that. Again, NMOS which are connected in series, parallel, or any combination logic. So always PMOS should be connected to the VDD and output, and NMOS should be connected between output and the ground, that is VSS, and all the inputs are connected together and output is taken in between the PMOS and NMOS circuitry, that is pull-up and pull-down network intersection. We are taking the output. So A plus B, as my practice is that to draw NMOS first. Depending upon your simplicity, you can draw anything at the start. So I am drawing NMOS first. So A plus B, plus means for NMOS it is parallel. So I required A means one transistor, B means another transistor. So one transistor, second transistor, plus means parallel. So I have connected this parallel. Same opposite of that you need to do for the PMOS. So this will be in series, and intersection at this point you are taking output, and A is connected with A and B is connected with B. Now suppose this equation is not given and only diagram is given to you. How to recognize that? That in NMOS, that is pull down network, both are in parallel. Parallel means plus. So A plus B, and complement of that is nothing but your expression. And I shown you how to justify this truth table. So which device will be turned on and off, depending upon that there will be a connection and you will be getting output. That is at this point what you are getting, either VDD or ground, because these all devices are acting as a switching devices. Okay, so only pull-up network or pull down network at a time both will not be on, only at a time one network will be on. So this is the functionality of CMOS. So hope this point is clear with you. So I am going with the next thing, poll question that we have taken earlier. So I'm not going in detail. PMOS, first answer to the first question is that or and. Second is NMOS and or, and CMOS invert the logic. Yes, it gives the inverted logic. This we have taken on the book lab. So 2-3 students have given answer, but correct answer is what? This one, which I have written over here. Now again I'm just explaining you related to this. Now as I told you, A plus B, what is meaning by, as my practice is to draw first NMOS devices. So NMOS devices always connected in the pull down network. So this is my pull down circuitry, from this to this pull down, which is connected to ground, and this is the pull up which is having PMOS connected to VDD. Hope everyone is having its their pen and paper with them. So parallelly you need to draw with draw. So A plus B. So NMOS. How many NMOS are there? A, B means two variables means two NMOS. So I am having two NMOS, plus means parallel connection. So NMOS are in parallel. So A and B, these are connected in parallel. Dot indicates what? Series. So series means straight line. Again C plus D means this whole thing is in parallel with this whole thing. So C plus D means C parallel with D. So A parallel B is in series with C parallel with D. So this is my pull down network consisting of NMOS. Same way, opposite to that is for the PMOS, means now AB are in parallel. So here AB are in series. So diagram you need to mention PMOS by showing bubble over here, otherwise everything will be wrong. So AB will be in series, and this series combination will be in parallel with again series combination of CD. So this AB is in parallel with CD, series combination of CD, and in this way your circuitry of this A plus B into C plus D whole complement is ready. If this whole complement is not there, what you need to do? Suppose this complement is not there, means you need to apply one inverter, CMOS inverter, as we have seen earlier, that you need to put it over here. Okay, so this thing is clear. I hope that you understood the thing. I hope this point is clear with you. Again, you need to do the practice. Again, next problem I'm taking. Suppose this is the CMOS EXOR gate. What is CMOS EXOR gate? That you already know, that I'm not going in detail of that. So this is the EXOR gate having two input, which is denoted by this particular symbol A plus B. Again, in the same another way, it is represented by Y equal to A bar dot B plus A dot B bar. This is the thing. Now, how to implement? As I told you, CMOS logic implement the inverted logic, but here complement is not there, whole complement is not there. So how to implement this logic? This logic can be implemented in your normal way. As I told you, what to do? I have written here for your understanding. NMOS, when dot is there, it is considered as a series, and when plus is there, it is considered as a parallel. Again, dot is there, series. And opposite to that, we have to consider for the PMOS. So this I have already told you, just for your understanding, I have written in this way. Okay. So now what you need to do for NMOS, A bar should be in series with B. So here, this is the A bar is in series with the B. Now this particular thing is in parallel with this particular series combination. So what is this? A B bar. So here is the A B bar, which is in series. Now these two parts are in parallel, so that's why this is a parallel combination. So this NMOS part, that is pull down network, is clear. Next, what you need to do, exact opposite of this, you need to draw at the upper side. So now here A B bar are in series. Now here A B bar will be in parallel. So this is A B bar. Already I had this point is clear with you. So for what we have done, this is opposite to this NMOS, we need to do the PMOS. So here what we did, we have first drawn this NMOS, that is A bar B in series. So this A bar B, these are in series. Again, this is in series, and both are in parallel. Same way we have did for the PMOS. Opposite of this, that these are in series. So here it will be in parallel, and series with this particular parallel combination will come. So like that we have written. Now, why we have connected this CMOS inverter in front of this? Because I already told you CMOS logic implements inverted logic, and as we know over here, what is happening? There is no complement is present. So that's why I need to implement this logic. So whatever CMOS is implementing, it is implementing complemented logic. To remove that complement, because I don't have complement, I need to connect this CMOS inverter. Okay, so for this we can do the things like this also. But now what is the problem? As we want to reduce the number of transistor on a chip, we can remove this particular part, CMOS inverter. So for that, what we need to do? Hope this particular thing is clear to you. We have done in the normal way whatever I told you previously, but as complement sign is not there, that's why you have just applied one CMOS inverter. But because of this, your logic is having more transistor. So to remove the number of transistor, what thing we can do? So second way to implement this circuitry, same circuitry I have now here. So what you need to do, just see over here in previous slide, what you are able to see, you are able to see one circuitry, that is 8 transistor, 4 PMOS and 4 NMOS, and again one CMOS, which is having one PMOS and one NMOS. So total there are how many transistors? 10 transistors. So if I want to reduce the number of transistors, I have to go in this way. So what is the another way for drawing this diagram? So what you need to do, now I want output to be in the complemented form. Okay, I want my equation to be in the complemented form, like it is complement is not present over here. But now to solve this particular thing, what I am taking, I want to rewrite this term in terms of this complement. So how to draw that, rewrite the term? So I am drawing two complements. What is meant by two complements? Complement will get cancel each other. So there is no effect of that complement, whatever I am writing. So I have written here two complements. Okay, and whatever the equation was previously given, that is written here. Okay, now what I need to do, I need to solve only these particular equation. I want this complement to be there because always CMOS logic implement inverted logic. Okay, so I am solving only one complement and this particular equation. So as I told you in previous lecture, I am not going in detail of this because this is first year you have covered this De Morgan's theorem. I am just repeating: complement of product equal to sum of complements, and complement of sum is equal to product of complements. So same way you need to solve, and after solving what you are getting, this will get cancelled with this 1 and 1 bar, that is 0 into 1 will be cancelled, and you will be having this particular thing. Again you will able to see this particular structure. Actually complement of EXOR is nothing but EXOR. So same equation you are able to see over here. Okay, so this type of equation you got, and now for this equation there is one complement present over here. So I can directly implement this CMOS circuitry without inverter. So likewise it reduces your two transistor. So this is the best way to implement. Just you need to solve this De Morgan's theorem. Using De Morgan's theorem you need to solve this. So now how to implement this A into B, because complement is already inbuilt, because CMOS in logic implements the complementary logic. So I need to implement this particular logic. So A into B is what? A into B means for NMOS it is series. So here two transistors are in series, A, B. Plus means parallel. So here is the parallel combination. Again series combination of B bar, A bar. So series combination of B bar, A bar. Opposite of this you need to implement in the PMOS. So as these are in parallel series, this will be in parallel. So this is parallel. Again this is in parallel. So this will be in series. So it can be written like this also, like this, then like this, and then like this. This is the way you can draw. So again B bar and A bar, here they are in series. So here it will be in the parallel. And likewise you will implement same logic just by manipulating certain things in the equation. Normally you don't have to manipulate the equation, but when this case like a inverted logic is not there, you need to create an inverted logic. Okay, so there are two things logic different ways I told you, that is previous, in which you need to apply CMOS inverter in front of your logic, and here to reduce the number of gates we have done this De Morgan's type of manipulation. Just I want to take multiple examples so that it will be easy for you to understand. So this is the EXOR gate. Now EXOR gate. So EXOR gate, how you can implement? First method is that normal logic you can implement, and in front of that just implement CMOS inverter. And second logic I told you to use the De Morgan's theorem. So I have used De Morgan's theorem. So what you need to do? I need to manipulate the equation. So for that I have applied two complements, because complement cancel each other, means there is no effect of whatever the changes I have made in the equation. So after solving I am getting this equation. Now complement sign is there, means without inverter I can implement my logic. So A B bar. So this is NMOS implementation dot is series. So A B bar in series. Parallel with that you are having series combination of B A bar. So this is B A bar. So parallel combination of with this. Opposite of that you need to do with the PMOS. So same way you are able to see this structure. Okay, so hope these things are clear. If not, just do the practice. Now here I have shown one example. In your book you need to try find out the equation of this. I'm giving 30 seconds of time. Just try for this. What is the equation? What will be the equation? Because I told you in the both the way, from equation how to draw the diagram, and from diagram how to find out the equation. So how to do? Just try for it. I'm giving 30 seconds for you. So here, as there are 1, 2, 3, 4 variable equation will be there. Okay, try with me parallelly. Okay, so here A is over here. Series with that I am having this combination. So can I write A, because I am solving for NMOS. Okay, so I am writing this A. Hope I am able to write it properly. So this is A series with this combination. So series means for NMOS it is the dot multiplication. Now whole this circuitry will be in series. So I'm just taking one bracket to avoid the complication, because this whole structure is in series with this. So what you are having B. So what is B? B is normally in series, but parallel to this, B के parallel में क्या है? This structure. So parallel to B, we are having structure. So I am writing plus. For NMOS, parallel means plus. Now what you are having? Series combination of C and D. So series means into. So sorry. And this is my bracket is complete, and complement logic it implements. So this is the bar. So hope these things are clear to you. So what is the equation finally you got? That is this one, right? Which I have written previously. So A means this is A. Series with that, there is a whole combination. So series to A, we are having the combination of this. So what is in the combination? We are having B. Parallel with B, we are having series combination of CD. So parallel means plus, series combination means C into D. And whole complement, because I told you that CMOS logic implement inverted logic. So hope this thing is clear. I have just made this particular box to hide the things. Okay. So hope these things are clear to you. So both the way you need to do that. If the equation is given, you should be able to draw the diagram, and if the diagram is given, you can do the reverse engineering and to find the equation. So hope the things are clear. Yes, Pranjal, you have written, but something brackets are more. Okay, no problem. You are at least tried. Thank you. So next we will see this one, and this is the last example, and you need to do the practice of this. Take any example by your own and try to implement that particular circuitry. Without complement also you should take and solve using De Morgan's theorem to reduce the number of transistors. So this is the circuitry. So in the simple way, what is written? A plus B. Now if I want to try using NMOS first, so A plus B means A parallel with B. So this is A parallel with B, and NMOS will be in the pull down network. That's why I'm drawing in between output and the ground line. So A parallel with B. But in this, again, there is multiplication side with C, means this whole A plus B is in series with what? C. So this is whole A plus A parallel with B is in series with what? C. Okay. Now this structure again is in series with what? Parallel combination of C plus E. Sorry, D plus E. So this is in series with parallel combination of D and E. So hope you have understood now. Main thing is that you need to remember this thing. You need to remember where to draw the PMOS and NMOS, pull up, pull down. This thing you need to draw. And last but not the least, that you need to remember the symbol. If you are not drawing bubble, means you know, but because of certain hurry, you are not drawn the that bubble, then it is a totally wrong concept. Okay. So again, opposite of this, we need to implement over here. So AB in parallel. So here it will be in series. C is in series with that, so C will be in parallel with that. Again, this is in series with whole combination, so again it will come in parallel. This is parallel, so this will come in series. So that way, just opposite of this, no need to remember all the things at all. Just remember any one, opposite of that, you need to go for the other. So don't forget to write that equation over here. Here it is not written, but you need to write this equation. And this is the complemented equation, means there is no need to draw CMOS inverter. So that is written over here. A plus B for PMOS, plus means series. So these are series. Into, that is parallel. So these are in parallel. Again, this is series. Again, dot means parallel. So again, parallel. Plus means series. Likewise, they are drawn. Likewise, just do the practice. Hope you will be doing any type of combination logic using CMOS very easily. Okay. And this is again, I am repeating last time that this is you need to implement in microwind for the VLSI practical. There are 3 types of practicals. Out of that, one is related to this CMOS logic implementation. So here, just try to write drain source things also. I told you that in PMOS, source will be in the upper side. VDD ko kya connect hai? That is source, and drain at the downside. But for the NMOS, VSS ko kya connected hai? That is connected as a you can say source is connected to this ground side. Here source is connected to PMOS, source is connected to VDD, but here NMOS source is connected to ground. That you need to remember. And why this is happening? Because I told you the concept of body effect. For body effect, to reduce the body effect or avoid the body effect, what you need to do? For PMOS, body should be connected to positive. So positive, and along with it is should be connected to the source, and that's why it is connected to positive. That way also you can remember. Okay, so hope these things are clear to you. So without wasting most of the time, again I'm just going towards the summary of this, and this is very important. So CMOS logic has PMOS in pull-up network and NMOS in pull-down. Hope this is known to you. Why we need to connect PMOS in pull-up and NMOS in pull-down? If that question is asked to you, you need to justify that PMOS passes strong 1 and NMOS passes strong 0. So that I have taken everything by considering or swapping the position of PMOS and NMOS. Okay, now when PMOS turns on for the logic 0, and NMOS turns on for the logic 1, because PMOS is an active low device and NMOS is an active high device. So active low means for 0 it will turn on, and once it is on and as it is connected in pull up network, it passes strong 1. Okay, and NMOS passes strong 0. And as CMOS logic is related to PMOS and NMOS, only one circuit will be on at a time, and that's why there is a low power dissipation. Okay, so this we have cleared. For NMOS, whenever there is a into B, transistor will be in series, and A plus B transistor will be in parallel. Same way for the PMOS, opposite of this, and just you need to remember that bubble you need to put in front of that gate.